So, good morning to all and welcome you all for the 10th lecture on electronic circuits 1. So, this is lecture number 10. And to summarize the last class, last class we started with the emitter bias, right? So, anyone, how to sketch the circuit diagram for emitter bias? So, how will you sketch the circuit diagram for emitter bias? Why is it so called emitter bias? So, you want to start with what is that? Fixed bias. So, fixed bias, you know how to sketch the circuit diagram, right? Common emitter. So, emitter must be grounded. It must be common, right? For both input and output. And here you will give this biasing voltage VCC. This is my RC. So here you will connect this input resistance, namely RB. So here also I want to give the same biasing voltage VCC. So this time emitter bias, as name indicates. So what I am going to do? I am going to connect one emitter resistance RE. Okay. So this is the DC equivalent circuit diagram of emitter bias. So you know what is the entire circuit. Here I want to give this VI through input coupling capacitor CI. So here you will measure the output through output coupling capacitor C out. Okay. So what we discussed, anyone? We started with the DC analysis, right? Yeah, DC analysis. First step, we have drawn the DC load line. So what are all the reference points? Anyone? What is the A point?
VCC, 0.
Okay, what is the B point?
0, VCC by RC by plus RE.
So 0, VCC. This time this is RC plus RE. Okay, because you included RE. Okay, you know how to sketch the DC load line. Okay, then Q point. This is my DC load line. Okay, coming to Q point. This is subdivision A, subdivision B. Q point. Okay. So what is IC general formula? IC equal to beta times IB. Where IB? What is the formula? Anyone? Without referring anything, is it possible? So IC equal to VCC minus VBE. This time RB plus 1 plus beta times. What is this? RE, right? Input side. So RB plus 1 plus beta times RE. So you know how to find IC. Then what is the value for VCEQ? Nothing but VCC minus IC times RC plus RE. Okay. So after that, how Q point is maintained, that is very important. So how Q point is maintained, anyone? This time I want to start from if IC increases, what will happen? Remaining and all, you know it, right? When temperature increases, three transistor parameters are changing, the same story. Suppose if IC increases, right? Because of the changes in the three parameters, so IC increases, then how are you going to decrease the IC? Anyone? IC, what will happen?
IE increases.
So IE increases. Okay, if IE increases, what will happen? VE increases. If VE increases, what will happen?
IB decreases.
If IB decreases, what will happen?
IC also decreases.
So right, so this is the way we are compensating IC. So what is the advantage of connecting RE? It's very important. So what's the advantage? To increase?
Increases the
stability. Okay, so it is providing much stability when compared to fixed bias and collective to base bias. Okay, then what's the drawback? So now coming to drawback. So in order to understand the drawback, now put the it to derive stability factors. So now coming to today's topic, to derive stability factors, we will derive one by one. Okay, so first to derive S, to derive S. Okay. So you know what is the flow? Okay, to derive S, we know the general expression for S. So we know that general expression for S is equals 1 plus beta divided by 1 minus beta times change in IB with respect to IC. So you want to calculate this change in IB with respect to IC. So in order to calculate the change in IB with respect to IC, what do you want to do? So you want to apply KVL at input loop. Okay. But this time you want to develop IB in terms of IC. Okay. So at input loop, you know, your applied voltage VCC, this equation already we developed. That way I'm going to write it. So applied voltage VCC coming here, input loop, right? Applied voltage VCC. Here the voltage drop VRB Here the voltage drop VBE, and here the voltage drop IERE. Okay. So straight away I'm going to write VCC equal to the voltage drop across RB, the voltage drop between base to emitter, plus the voltage drop across emitter, nothing but IERE. But this time I want to write IB in terms of IC. So this is voltage, so no need to worry about it regarding VCC and VBE. Here IB is present, so no problem. But here IE is present. So how will you rewrite the equation? So IBRB plus VBE plus what is IE? In terms of IBIC, you know the general transistor current equation, IE equal to IB plus IC. Okay. Since IE equals IB plus IC. Okay. So now take IB as common. So here you are having RB and here you are having RE. So RB plus RE times IE. Okay. Plus what about this one? IC times RE plus VBE. This is my VCC. I'm looking for actually what I want to do. I want to find the change in IB with respect to IC. So now differentiate the above equation, right? With respect to what? IC. So what is the differentiation of VCC with respect to IC? Will give you 0. So differentiation of IB with respect to IC. So here RB plus RE is constant plus differentiation of IC with respect to IC times RE plus differentiation of VB with respect to IC is 0. Okay. So what I am looking now, what is this? This is okay. Change in IC with respect to IC becomes 1. I'm looking for the change in IB with respect to IC. So you will get minus RE divided by RB plus RE. Very important, right? So now take this is equation number 1 and take this is equation number 2. Okay. Now substitute equation number 2 in 1. So what you will get? S equal to 1 plus beta divided by 1 minus beta time change in IB with respect to IC is minus RE divided by RB plus RE will give you 1 plus beta divided by 1 plus beta times RE divided by RB plus RE. Okay. So this is my stability factor. It's very important. Now, what is the approximation here? Anyone? What is the relation between RB and RE? Whether RE is very greater than RB or RB is very greater than RE in practical.
RB very greater than RE, sir.
Why? So RB is very greater than RE. Why? Why? Justify.
Base count of microelectrons.
Yeah, thank you. So you know IB always in terms of microamps, IE almost equal to IC. இது எப்படி இருக்கும் milliamps ல இருக்கும். Okay, you know the relation between RB and RC, right? RB is very greater than RC. In the same way, RB is very greater than RE. Okay, so if RB is very greater than RE, then what is RB plus RE? Anyone? What is RB plus RE almost equal to RE or RB? RB. Then what is RE by RE plus RB plus RE, which is very less than 1. Then what is beta times RE plus RB plus RE may be very less than 1. Okay, so when compared to this one, this beta times RE plus RB plus RE is negligible. Therefore, what is our stability factor? Almost equal to, again same drawback. Yeah, Q point is maintained, stability is improved, but what is happening? High stability factor. That is the drawback. High stability factor, drawback of emitter bias. Okay. Yesterday I have given one relation. Okay. What is the relation between RC and RE? I told RC is very greater than RE. Okay. Actually, in order to give this relation, okay, simply I confused you people. Huh? Yesterday I have given this. What is this? Yeah, I have given change in IB with respect to IC. It's nothing but RE divided by what I told, RC plus RE. But how RC will come into picture? We are applying KVL at the input loop. At the input loop, there is no RC. Actually, it is RB. But why I have given this equation? Because you want to know, as I told yesterday, RC. You want to know all the relation. Okay, in practical, you want to know what is the relation between RB and RC, and you know what is the relation between RB and RE. Now you want to know what is the relation between RC and RE. Okay, so here RC is very greater than RE. Why? When you will be designing the amplifier, at that time this concept will help you. Okay, and what is the need for having RC is very greater than RE? That you will understand when you will be designing. You don't worry. So time being, just to keep it in your mind, RC is very greater than RE. So now coming to today's lecture. Yeah. So you take this. This is the way to derive the stability factor. Yes. Okay. For emitter bias. So any doubt? Guys, are you with me? Praveen?
Sir, no sir. Arthupal sir.
Shall I move? Thank you. So now to derive S dash. Put the heading to derive S dash. As I told earlier, if S dash, I won't derive S dash. Okay. No need to derive S dash and S double dash for emitter bias and voltage divider bias because it is same. Okay, as in collector to base bias. Any guess, anyone? How to derive S dash? Okay. What is the S dash for collector to base bias, otherwise feedback bias? Anyone? S dash and S double dash. Anyone? S dash என்ன வந்துச்சு feedback biasல?
Beta divided by minus beta, sir.
Minus beta. Minus beta divided by
RC into 1 plus beta
RB plus 1 plus beta times
RCC.
RC. What is your S double dash?
IC into S
IC divided by beta will be multiplied by S and
S by 1 plus beta.
super beta. Okay. Now any guess what would be your S dash for emitter
Sir,
bias?
minus beta by RB plus RE, sir.
So what is your IB for fixed bias? IB for fixed bias, anyone? What's the value for IB in fixed bias? என்ன வந்துச்சு? IB equal to I equal to V by R. So this is VCC minus VBE divided by RB plus 1 plus beta times RC. Whereas emitter bias என்ன எத்தனை பேருக்கு புரியுதுன்னு தெரியல. கிளாஸ் லெசன் ப்ராப்பராக லிசன் பண்ணியிருந்தேன்னா திஸ் கான்செப்ட் யூ கேன் அண்டர்ஸ்டாண்ட். ஓகே, நான் திரும்ப சொல்றேன், இந்த அளவுக்கு டெப்தா போயிட்டு இதை நடத்தணும் அவசியமே இல்லை. நான் நினைச்சா ஜஸ்ட் எல்லா ஃபார்முலாவும் டெரைவ் பண்ணிட்டு நான் பாட்டு போய்கிட்டே இருக்கலாம். பட் ஒய் ஐ ஆம் கிவிங் ஆல் த ரிலேஷன், ஸோ ப்ளீஸ் ட்ரை டு அண்டர்ஸ்டாண்ட். சர்க்கியூட்டு ஐ ரிப்பீட் இட்ஸ் வெரி டிஃபிகல்ட். யூ ஸ்டடி ஆஸ் இட் இஸ். ஓகே, ஸோ த திங் எப்பயுமே ரிலேட் பண்ணி படிக்கிறது இட் வில் கிவ் யூ தி கிளாரிட்டி. ஓகே, இஃப் இட் இஸ் கன்ஃபியூசிங் யூ பீப்புள் ப்ளீஸ் லெட் மீ நோ, தென் ஐ வில் ஸ்டாப் திஸ் கைண்ட் ஆஃப் டீச்சிங். Okay, what is the IB value for emitter bias?
VCC minus VBE
divided by
RB plus
RB plus 1 plus beta
times RE.
RE. So what is the difference? RC is replaced by RE. So it's a very important point. RC is replaced by RE. So what would be the S dash for emitter bias? So minus beta divided by RB plus 1 plus beta times RE. So S dash, again there is no change. So IC divided by beta into S divided by 1 plus beta. But where S? Here what is the value for S? And here what is the value for S? Here S equals 1 plus beta divided by 1 plus beta times RC divided by RB plus RC. இந்த அளவுக்கு இருக்கணும், fluent இப்படி வரணும். இது எப்போ வரும்னா after having enough practice. So here where S equal to 1 plus beta divided by 1 plus beta times, here this time RE divided by RB plus RE. Okay, you please make a note, it's very important. So now, no need to derive this separately. Okay, you guys, you please derive by yourself. You know how to derive the S dash and S double dash. Okay, for collector to base, take the same derivation, same flow. Okay, adula just you want to replace RC by RE. This is the keyword. Okay, same flow. And you guys, you please derive this. Take it as an assignment. Similarly, you want to derive S dash and S double dash for the next biasing, voltage divider biasing also. So take these two derivations. Okay, totally 4 derivations. S and S dash, S dash and S double dash for emitter bias and voltage divider bias. Take it as an assignment. Date of submission. You guys, you please. Who is the volunteers for girls? Arrow சொன்னமே யாருமா?
சார்
சொல்லுங்க.
காவ்யா சார்.
காவ்யா, என்னைக்குமா டேட் வச்சுக்கலாம்?
நீங்களே சொல்லுங்க சார்.
இல்லம்மா, நான் சொல்லி போர் அடிக்கு, நீயே சொல்லு. Take your own time, no problem. இன்னைக்கு என்ன கிழமை? புதன்கிழமை. Okay. Okay, Sunday. So any doubt in emitter bias? Now the most interesting part. Okay. So now put the heading voltage divider bias, and before that, night தூக்கத்துல திடீர்னு ஒரு தாட் வந்துச்சு. பொட்டன்ஷியல் டிவைடர்னா என்னன்னு தெரியுமா உங்க பசங்களுக்கு அப்படின்னு. அதனால காலையில எழுந்துட்டு வாட்ஸ்அப் குரூப்ல ஒரு வேலையை பார்த்தேன் இல்லையா. ஃபர்ஸ்ட் யூ வாண்ட் டு நோ voltage divider. The other name for this voltage divider is potential. Other name for voltage is potential, right? So voltage divider or potential divider. மார்னிங் வாட்ஸ்அப்ல ஒரு கொஸ்டின் கேட்டிருந்தேன். எத்தனை பார்த்தீங்க ஃபர்ஸ்ட் புரிஞ்சுன்னு தெரியல. எனி ஒன் காட் தி சர்க்கியூட்? That is the test your understanding in circuit analysis, not in EC1. So anyone have you developed that circuit? So what I have given? What is the question? The question is, yeah, design a potential divider circuit, right? Potential divider circuit to get 8 volt, then 5 volt and 1 volt, right? And assume the input voltage is some 10 volt. So anyone got the circuit? You guys please. If no, please say no. Then I will teach you. Yes, are you with me?
No, sir.
Okay. So when voltage will be divided in series or parallel connection?
Series, sir.
Series. Okay. So take this is my 10 volt applied voltage. Okay. So what you want to get 8 volt, you want to get 5 volt, and you want to get 3 volt. Sorry, 1 volt. Okay. So you want to connect 3 resistors in series. Yeah. In such a way. So connect 3 resistors in series. Okay. Listen it carefully. It's very important. What I told, you want to get 8 volt. Suppose if you will measure here, then you want to get 8 volt. And if you will measure here and you want to get what is this? 5 volt. Okay. If you will measure here, what you will get? Any idea? So in order to get 8 volt, 5 volt and 1 volt, how many resistors will you connect? 3 or 4? Actually 4. Why? That you can understand after some time. Okay, because we are in need of
3 பண்ணும்போது லாஸ்ட்ல 0 ஆயிரும்டா சார்.
0 ஆயிடும்.
கிரவுண்ட்
because last எங்க இது கிரவுண்ட்ல கனெக்ட் ஆயிருக்கு. so last 0 ஆயிரும். அதனால you are in need of 4 resistors. Otherwise always to measure voltage, okay, you are in need of 2. What is that? 2 terminals. So take one as always take as reference. So here if you will connect, if you will measure, you want to get 1 volt. So now what could be the value for this R1? What could be the value for this R2? What could be the value for this R3? R4? Any guess? You are applying 10 volt, ma. I am applying 10 volt. If I will measure at this point, I want to get 8 volt. Apna enna artham? Here to here, right? Plus 2 minus. Here to here, total voltage is 8 volt. Then what is the voltage drop? Then what is the voltage drop across this R1? Anyone? 2. Yeah, very good. So here the voltage drop must be 2 volt. Yeah. Okay. Now coming to R2. What could be the voltage drop across? Yeah.
3
3
volt.
சார்.
3. Yeah. Who is that? Very good.
பூரா
Coming to R3.
4 சார்.
4 volt. Why and how? Can you justify?
சார் ஆர் ஃபோல்ட்ல வந்து 1 வோல்ட் டிராப் இருக்கு சார்.
Okay. So
அப்போ
now if
கிரவுண்ட்ல
we
இருந்து
will add all these, okay, then what you will get, you will end up with 10 volt, right? So applied voltage which is equal to sum of all dropped voltages. Yeah, very good. Yeah, you justify in your own language. I will give it 2 minutes.
சார் கிரவுண்ட்ல இருந்து பார்க்கும்போது R4ல 1 வோல்ட் டிராப் இருக்கு சார். அதே மாதிரி
Okay.
கிரவுண்ட்ல இருந்து 5 வோல்ட்டுக்கு R3 plus R4 வந்து 5 வோல்ட் சார். ஸோ R4ல
Yeah.
1 இருக்குங்காட்டி R3ல 4 இருக்கணும் சார்.
Okay. So don't go with reference. Now coming from upwards, whatever you are explaining, it is correct. But please, can you come from upwards?
எஸ் சார்.
Here you
இப்போ
are applying 10 volt, right? Yeah.
10
Now
வோல்ட்
yeah.
வருது சார். பாயிண்ட் ஏல வந்து 8 வோல்ட்ங்கும் போது R1ல 2 வோல்ட் டிராப் இருக்கும் சார்.
Okay, அப்ப இங்க 8 volt வந்துரும். Okay.
Yes,
Here
sir.
you will get, here you are
5
having
volt.
3 volt, so you are getting 5 volt. இங்க ஒரு 4 volt, so 5 minus 4, you will get 1 volt, right? So the same circuit, how can I draw? In a simplified manner, can I draw like this? Okay, it is grounded. This is my applied voltage, 10 volt, and this is my. Now what is the value for R1, R2, R3, R4? Anyone? This is my R1, this is my R2, this is my R3, this is my R4. So take R1 equal to 2 ohm. Can I take R1 equal to 2 ohm? So this is my 3 ohm, and this is my 4 ohm, and this is my 1 ohm. Okay. So 2 ohm, 3 ohm, 4 ohm, 1 ohm. Now what is I? I equal to V by R. Here R equivalent, and V is 10. What is R equivalent? All are contained in series. It is 10. So 1 amp, right? So now what is the voltage drop across R1? What is the voltage drop across R1? I equal to V by R. Sorry, what is the voltage drop across R1? Not I, V. What is the voltage drop across R1? V equal to I times R, where I equal to 1 amp, R equal to 2. So 2 volt. Are you getting 2 volt? So what is the voltage drop across R2? Again same current, but this time 3. So 3 volt. What is the voltage drop across 3? Across 4 ohm, right? R3 across 4 ohm. So it becomes 1 times 4 will give you 4 volt. What is the voltage drop across R4? 1 times 1. So 1. If we will add everything, we will get 10 volt. Okay. So this is a simplified version of this circuit, right? Both are equal actually, but this is a simplified version. This circuit is called voltage divider, or otherwise this is called the potential divider, because you know what is happening here. You are applying some 10 volt. It is divided, right? It is divided as 8 volt here, and 5 volt here, and 1 volt, right? So this circuit, it is called potential divider, otherwise voltage divider. Okay, the same concept I thought in circuit analysis under the topic voltage division rule. Okay, same. அங்க ஒரு 2 resistor connect பண்ணேன். That is application of voltage division rule will give you potential divider. So got the idea why this circuit is referred as a potential divider as voltage divider? Got it? Guys, are you with me?
Yes, sir. Got it, sir.
So now design a potential divider by yourself. Okay. To get 12 volt and 8 volt. Okay. Assume the input voltage is some 20 volt. Can you do by yourself? Take 2 minutes time. And I will call you randomly, and you want to show your notebook, okay, through your camera. Is it okay for you people? Anyone is ready to show your circuit diagram via your camera? The question is design a potential divider, otherwise design a voltage divider circuit to get 12 volt and 8 volt. Assume the input is 20 volt. You can choose your own R1 and R2. Nothing wrong. Guys, concept purincha. Is it understood? The concept, is it clear or not?
Yes, sir.
Okay. Anyone have you developed the circuit diagram? So here you are in need of two voltages, namely 12 volt and 8 volt. So how many resistors?
3 resistors, sir.
So 3 resistors in series. Okay. So 3 resistors in series. Yeah. 3 resistors in series. Okay. And you will apply. What is the input voltage? 20 volt. Okay. So here you want to get, if you will measure, here you want to get what is 12 volt. And here you want to get 8 volt. Okay. Now what is this R1? Take this is R2 and this is R3. So what could be the value for R1?
8 ohms.
8. Okay. What could be the value for R2?
4 ohms.
What could be the value for R3?
8 ohm.
8 ohms.
8 ohms.
8 ohm. So can I take R1 equal to 80 ohm? If I will take R1 equal to 80 ohm, what could be the value for R2? What could be the value for R3?
40.
If R1 equal to 40, this is
80.
Can I take R1 equal to 32 ohm? If R1 equal to 32 ohm, what is R2? What is R3?
16 and 32.
You guys, are you ready to play?
16.
16 and 32.
Are you playing?
1632.
Sorry?
1632.
What could be the value for R2?
1632.
16.
1632. So if you know the concept, then it is easy to play. Okay. Here you may have a doubt. Why this guy he has chosen R1, R2, R3, R4 as 2, 3, 4, 1. Not only 2, 3, 4, 1. You can, if you want to go with 20 ohm, yeah, you can go. If R1 equal to 20 ohm, then what could be the value for R2, R3, R4 that you want to play? Okay, with the circuit. So once if you know the concept, this is fundamental. Okay, not that much difficult and all, but you want to know. Okay, so this is the way to design a potential divider. Okay, voltage divider circuit. So now let me put the heading. The interesting biasing called what is this? Voltage divider biasing, VDR, voltage divider biasing. Otherwise, this is called potential divider biasing. Otherwise, this is called self. Okay, so you know what is the drawback of fixed bias, and you know why you moved to culture to base bias, and you know what is the advantage and disadvantage of culture to base bias. Again, disadvantage. That's what we have moved to emitter bias. Now you know what is the drawback of emitter bias, high stability factor. I'm looking for S equal to 1. As I told earlier, till until I get S equal to 1, anga varaikku oya maten. Okay, so now this concept is quite interesting. Why is it so called potential divider? Why is it so called voltage divider? Yeah, self biasing. Okay, okay. Now one guess, anyone. I will ask one question. In both collector feedback bias as well as emitter bias, what is the drawback? Collector to base bias la RB is very greater than RC. This is on the C to B la. And E la enachu emitter bias la RB is very greater than RE. So in both fixed bias, who is giving the headache? Anyone? Who is giving the headache?
RB, sir.
RB, yeah, RB. So, is it possible to remove RB in transistor? That is never possible. But we can modify, right? So that's what one genius like you people, he came with an excellent circuit, you know, how to sketch the circuit diagram for voltage divider bias. So this time take emitter bias. Or only panala, persala only panala. Simply he did one thing. Simply he did only one small modification that will give you, okay, the reasonable circuit that will give you S equal to 1. So it's quite interesting. Now listen it carefully. So how to sketch the circuit diagram for voltage divider biasing? So you know how to sketch the circuit diagram for emitter biasing. So this time draw the emitter biasing. Okay, this is my RE, and here output side we will connect the biasing voltage through RC, and the input side also you will connect the same biasing voltage VCC. Okay, this is my RB and this is my VCC, right? Yeah, this is the DC equivalent full circuit. So you will give VI via input coupling capacitance, and you will take V out via output coupling capacitor. This is the circuit diagram for emitter bias. Okay, one gene is, that guy, what he did, simply he will connect one more resistance here. That's it. Now, how will you name this? Both are connected base, right? That's what this guy has given some other name. So this is R1, this is R2. So this is the circuit diagram for voltage divider biasing. But quite interesting circuit. Okay. So without this guy, you cannot imagine, okay, any amplifier. Take any amplifier in the world around you, okay, whatever it could be, we are using voltage divider biasing. So universally we are using voltage divider biasing, okay, for all amplifiers because it is providing reasonable stability factor. It is providing reasonable stability factor. Nothing but it is providing undistorted output, okay, and also it is maintaining Q point also. That's the beauty of this circuit. So now take this circuit. So here actually we are going to do the same. First we will start with the DC analysis. So let me start very first topic, DC analysis. Now what's the time?
11:45.
Okay, so 20 more minutes, right? Yeah. So what's the very first step? To sketch DC load line. Okay. How will you analyze this circuit? Since it is complicated somehow, right? Input side. Now what is this? Any guess? This is what you are doing. Why is it so called voltage divider biasing? What is this? What is this? I am applying some voltage VCC via R1 and R2, and I am taking this voltage. Okay, and I am giving this voltage to transistor. Right. What about this voltage? Nothing but the voltage across R2. So what is this? Nothing but potential divider. Potential is divided, and you are taking the voltage across R2 and you are giving this voltage as input voltage to the transistor. That's what this is called, voltage divider bias, potential divider bias, and finally self biasing, because he is the best one. Always our self is the best one. Okay, I don't know about you people, but according to me, I am the best. Okay, so yeah, I think so. We are the best, right? So you people also, you are best. You don't worry. Okay, that's what this is called, the self bias. So actually, what is this? This is potential divider. அதனால இதுக்கு பேர் என்ன வந்துச்சு? Voltage divider bias. Okay, circuit இப்படியே வச்சு play பண்றது somehow difficult. Okay, so what I am going to do now? Take this potential divider as it is, and what is this? And treat this is my load. Treat this is my load. Okay, so time being, first take, actually in order to do the DC analysis, okay, first what you will do, you will draw the DC equivalent circuit, right? So before sketching DC load line, first draw the DC equivalent circuit. Draw DC equivalent circuit. So what is your DC equivalent circuit? Let me draw here itself. Okay, so VA equal to 0, and you want to replace this capacitor by open circuit. So now this is my DC equivalent circuit, right? This is my DC equivalent circuit. Any doubt in sketching DC equivalent circuit? To sketch a DC load line, obviously you will apply KVL at output loop, and to find the Q point, obviously you will apply KVL at the input loop. But here, where is output loop? Where is input loop? Okay. Then since you are having two resistors R1 and R2, so I want to draw the Thevenin equivalent circuit. Okay. This time this guy will help you. So hope so you can remember. Once upon a time, long ago, there was a tall guy. Okay, and he has taught you Thevenin equivalent and how to sketch Thevenin equivalent circuit. Anyone? What are all the possible cases in a Thevenin equivalent circuit? Quite interesting theorem, right? ஒரு மூணு cases நடத்தியிருப்பேன். Anyone? Thevenin and Norton equivalent circuit, Thevenin Norton theorem. Case 1, all are, what is this? Independent sources. Case 2, at least one dependent source. Case 3, all are dependent source. ஆட்டோகிராஃப் பாடத்துல ஒரு பாட்டு வருமே, ஞாபகம் வருதா? Are you remembering those days? Those golden days, right? Yeah. தனியா உட்கார்ந்து அந்த தனுசு மாதிரி குழம்பு விட்டீங்கல்ல, இந்த மாதிரிலாம் இல்லாம so how we enjoyed that, never forgot all those days. கடைசி ஒரு கொரோனா வந்து நம்ம வாழ்க்கை எப்படி மாற்றிட்டு. So I'm going to apply Thevenin, okay, theorem to draw the equivalent circuit. Okay. So anyone, what is the procedure? What is Thevenin equivalent circuit? Any complex circuit can be replaced by, what is Thevenin?
A voltage source
in series with resistance. So here you will connect this load, right? Here we will connect this load RL. So voltage source, what is the name for this source? VTH. What is the name for this resistance? RTH. Okay. So you want to calculate VTH and RTH. So here who is the load? As I told you earlier, this is my load. This entire thing is load. So you want to consider the entire thing as load. Where it is connected? At this point. Right. So now this is my load. Okay. So what is the procedure to calculate VTH? Anyone? Can I rub this?
Open the load, sir.
So what is the procedure to calculate VTH? Can I write here? Procedure first to calculate VTH. Yeah, Vignesh, come on.
Open the load.
அதுக்கப்புறம் and find the voltage across it, right? Open the load and find the voltage across it. Can you remember this? The procedure to calculate VTH. You want to open the load and you want to find the voltage across it. That will give you VTH. What is the procedure to calculate RTH? Anyone?
To short the voltage source and open the current source.
So you want to replace all independent sources by its internal impedance. Same keyword. Anyhow, anywhere have you heard this? So replace. First step, you want to replace all independent sources by its internal impedances, which means that you want to replace voltage source by short circuit, current source by voltage source by short circuit, current source by open circuit. Okay. So here you are having only voltage source. So you want to replace voltage by short circuit. Okay. And current by, there is no current, so don't worry. After that, what you will do? And you want to open the load and find the resistance across it, right? And find the resistance across it. இப்போ புரியுதா ஏன் வந்து ஈஸி ஒன்று வந்துட்டு சிஏ ஹேண்டில் பண்ண ஃபேக்கல்ட்டி எடுக்கணும் அப்படின்னு. ஸோ தட் இஸ் த திங். இதே மாதிரி ஈசி டூவையும் ஈசி ஒன்று எடுத்த ஃபேக்கல்ட்டி எடுத்தால் நல்லா இருக்கும். ஸோ ப்ளீஸ் ப்ரே ஃபார் தட். ஸோ ஓப்பன் த லோட் அண்ட் ஃபைண்ட் தி resistance across it. Okay, so now can we apply this procedure here, and can you find the, so now put the heading to find VTH. Quite interesting. To find VTH. So what do you want to do? You want to open the load. So can I open the load? I'm opening the load. So I opened. Okay, and find the voltage across it, right? So where it is connected with respect to ground, right? So now what is my VTH? This is my VTH. So what is VTH? What is VTH? What is VTH? Therefore, VTH equal to the voltage across R2. What's the formula? You know VDR, right? Voltage division rule. You are applying VCC. It is dropped across R1 and R2. So what is the voltage across R2? As per voltage division rule. What is my flow? How you want to pronounce voltage division rule? How will you write the formula for voltage division rule? Applied voltage into
ECC into R1.
அப்படி சொல்லக்கூடாதுன்னு சொல்லியிருக்கேன். எப்படி சொல்லணும்னு சொல்லியிருக்கேன். Applied voltage into same resistance divided by total resistance. மெட்டீரியல்ல இது R1 எழுதியிருப்பேன். You please change that. Okay, it's R2. மெட்டீரியல்ல R1 தப்பா எழுதியிருப்பேன். You please change it. So what is VTH? You want to open the load and find the voltage across it. Load open பண்ணிட்டேன் இப்ப. அப்ப what is the voltage across it? Load இங்க தான் கனெக்ட் ஆயிருந்துச்சு இல்லையா? So the voltage at this point with reference to ground. Ground இங்க கனெக்ட் ஆயிருக்கு. So this is my voltage. Nothing but what is this? The voltage across VR2. So you know how to find the voltage across R2 by using VDR. This is by VDR, voltage division rule. அதெல்லாம் now இருக்கு இல்லையா? Voltage division rule லாம். So now got the idea why we studied circuit analysis. I hope so. And I hope so you enjoyed my maximum power transfer theorem, right? Yeah. So you know when maximum power will be transferred to the load. So you know when maximum power is transferred, right? That story and you might have remember. So this is the way to find VTH. So now how will you find RTH? Anyone? To find RTH? To find RTH, what is the procedure? You want to, what do you want to do? You want to replace voltage by short circuit, right? So can I replace this voltage source by short circuit? Short circuit na enna? Actually இங்க என்ன இருக்கு? VCC na எப்படி இருந்திருக்கும்? This is my plus, this is my minus, right? Minus எங்க கனெக்ட் ஆயிருக்கும்? groundல கனெக்ட் ஆயிருந்திருக்கும். இப்படி தானே இருந்திருக்கும். Now you want to this is my plus, this is my minus, this is my VCC. You want to replace this voltage by short circuit. அப்ப என்ன அர்த்தம்? இதுவும் கனெக்ட் ஆயிரும். அப்ப என்ன அர்த்தம்? இப்படி கனெக்ட் ஆயிருக்குன்னு அர்த்தம். Okay, first step over. We replaced all independent sources by its internal impedance. What's the next step? Again, you want this time you want to open the load. Load open பண்ணிட்டேன். Here load is open. Okay, here load is opened. And you want to find the resistance across it. So now it will give you RTH, right? When you are looking from here. Okay, so can I redraw here? This is my R1 and this is my R2. Okay, and I replace this voltage source by short circuit. Now and find the resistance across it will give you RTH. What is RTH? Anyone? Both are series or parallel. You know the golden rule? Okay, to connect the series and the parallel connection.
Parallel.
This is my RTH, right? This is my R2. So can I redraw like this? This is my R1. So that's for what is RTH? R1 parallel with R2. So now can you redraw the circuit? Circuit என்ன இருந்துச்சு எனக்கு? Now this is my load, right? I'm redrawing. My VCC, RC, okay, RE. Okay. So now என்ன பண்ணணும்? You want to connect the load here. So what is the equivalent circuit? So can I redraw? Very important. So what is the Thevenin equivalent circuit? Here RTH, sorry VTH, and here RTH. Then connect the load. This is my VTH. You know the formula for VTH. And this is my RTH. You know the formula for RTH. Then connect this load. VCC, RC, RE. Now is it possible to find input and output loop? Yeah, obviously. This is my input loop, right? This is my input loop. And this is my output loop. Okay. Initially, it was somewhat difficult, right? That's what I have moved to Thevenin equivalent circuit. I hope so you enjoyed this session. Okay, how to sketch the Thevenin equivalent circuit. I hope so this much knowledge you want to know. But luckily, we studied all these things in circuit analysis. Okay, if it is not understood, you please rewind this recording and please try to catch all the concept in Thevenin theorem and try to draw the equivalent. So where VTH equal to, so இதுக்கப்புறம் தூக்கத்துல தட்டி எழுப்பி கேட்டா கூட தெரியணும் what is VTH, the voltage across R2, that you know how to write the formula for R2, applied voltage into same divided by total resistance, right? So applied voltage into same resistance divided by total resistance. And what is RTH, that you know R1 parallel with R2. So this will give you R1 R2 divided by R1 plus R2. So now for this circuit, can you sketch the DC load line and can you find the Q point this time? Hereafter the process is simple. Okay, how to sketch the Thevenin equivalent circuit for voltage divider biasing? It's very important. Okay, so not only for voltage divider biasing, hereafter we are going to design the amplifier with the help of this voltage divider biasing. So for all kind of amplifier, so for very first step you want to design the voltage divider biasing. So with the help of Thevenin equivalent, then you can analyze all these things. So for DC analysis of voltage divider biasing, it is important to know about this Thevenin equivalent circuit. Got it? I will give you one clue. I will give you one concept. It's quite interesting. Okay. Yeah, இவர் வந்துட்டு ஒரு R2 connect பண்ணாரு. Now what is happening here? What is RB? Now RB becomes என்ன ஆச்சு? RTH. But what is RTH? It's a parallel combination of R1, R2. Now RTH, is it very, very greater than RE, or RTH, is it very, very less than RE? Hope you are enjoying. Are you realizing the essence of this circuit? It is beauty, right? யாரோ ஒருத்தர் ஒரே ஒரு R2 கனெக்ட் பண்ணாங்க. இப்போ என்னாச்சு? என்னால டிரான்சிஸ்டர்ல இன்டர்னலா என்னால போய் RPயை சேஞ்ச் பண்ண முடியாது. I couldn't change, the internal base resistance of transistor. But I can modify in such a way. I want to connect this R2. After that, what is RTH? Parallel combination என்ன ஆகும்? Suppose take some 100 ohm, அல்லது take some RB. என்ன இருந்துச்சு? R1 தான் எனக்கு என்ன இருந்துச்சு? RB. This R1 is nothing but what is this RB? This is very high value. It may be in terms of 1 mega ohm. But assume RE some 500 ohm. Okay, so this is RB. Now what I am going to do? This is R1 actually. I am going to connect some R2 in parallel in such a way. Now choose R2 equal to 100 ohm. What will happen? 1 mega ohm parallel with 100 ohm. What is the equivalent resistance?
Less than 100 ohms.
So less than 100 ohm obviously equal to 100 ohm, but this is very, very less than. This is 500 ohm, right? Sorry. Are you achieved S equal to 1? Have you achieved this? நீ என்ன பேசுறேன்னு புரியுறதுக்கு நீ என் கிளாஸ் ஃபுல்லாக ஒழுங்கு கொஞ்சம் தான் புரியும். பட் திஸ் மச் அண்டர்ஸ்டாண்டிங் இஸ் நீடட் ஓகே ஃபார் எலக்ட்ரானிக்ஸ் இன்ஜினியர். சும்மா வந்து நடத்திட்டு போயிருக்கலாம். இப்போ சிம்பிளி கனெக்ட் ஒன்று R2 அப்படின்னு போட்டு டெரிவேஷன்லாம் போட்டு டெரைவ் பண்ணிடலாம். பட் யூ வாண்ட் டு understand in a practical way. You want to realize it. Okay, as I told earlier, not only understand, you want to realize. Okay, are you realizing what is happening here? Now, without deriving stability factor, yes, straight away you can write S is almost equal to 1. If everything is understood by you people. Till now, what we learned, okay, in emitter bias, if that concept is understood, actually எனக்கு யார் தலைவலியா இருந்தாங்க, நான் அப்படித்தானே இங்க ஆரம்பிச்சேன். Can I recall this? RB. Okay. So now this RB is replaced by RTH. But RTH is nothing but the parallel combination of actually RB parallel with R2. I want to make this almost equal to R2. Now what I am doing, I am suppressing RB actually. But internally I will RB change பண்ண முடியாது, but I suppressed it, right? That is the beauty of this voltage divider biasing. Okay. What's the time now? So I think so today it is enough. Okay. Or otherwise you guys you do one thing. So now take this circuit. Now this is the Thevenin equivalent circuit of which one? Voltage divider biasing. இந்த கான்செப்ட்லாம் உனக்கு எந்த லெவலுக்கு புரிஞ்சுன்னு எனக்கு தெரியல. நான் சொன்னதெல்லாம் உனக்கு புரிஞ்சிச்சுன்னா யூ ஆர் வித் மீ. புரியலைன்னா நீ இது வரைக்கும் சரியா கவனிக்கல, இல்லை சரியா படிக்கலான்னு அர்த்தம். யூ டோன்ட் வெரி. இதை இன்னும் ஒரு 1000 வாட்டி ரிப்பீட் பண்ணுவேன் நான். ஓகே, யூ டோன்ட் வெரி. ஸோ இது வரைக்கும் படிக்கலன்னா கூட பரவாயில்ல, இன்னைக்காவது படிக்க ஸ்டார்ட் பண்ணு. ஓகே, ஐ ஹேவ் கிவன் எனஃப் மெட்டீரியல் அண்ட் ஐ ப்ரொவைடட் ஆல் த லிங்க். ஓகே, I hope so classலையும் with my satisfaction. Okay, actually I am satisfied, okay, through my delivery, but I don't know about you people. If I missed anywhere, okay, you please let me know, then I will stop, then I will teach you. So இது எடுத்த உடனே புரிஞ்சுக்கிறது கஷ்டம், but if it is understood by people, then I will be happy. So what I am speaking is very important. So now take this DC, I mean Thevenin equivalent circuit. So after that, hereafter, how will you sketch? So you will take this common emitter. There is no change in output loop. RE. VCC is my RC. So input side, it will be replaced by a single voltage source in series with a resistance. This is my VTH and this is my RTH. Where VTH, you know the voltage across R2, that is given by V times R2 divided by R1 plus R2, and RTH is nothing but the parallel combination of R1 and R2. So now put the heading to sketch DC load line. That's the very first step to draw DC equivalent circuit. Already then DC equivalent circuit. So next step, what do you want to do? You want to apply KVL at input loop. So apply KVL at input loop. Okay. Sorry, DC load line apply KVL output loop, right? Yeah. So output loop, this is my applied voltage, and what about this voltage drop across RC? Here this is I plus minus, the current is IC, so it becomes IC times RC. Between what is this? Collector to emitter, you are having VCE plus minus, and here this is plus minus IE times RE. So straight away I am writing applied voltage VCC, which is equal to the voltage drop across RC, the voltage drop between collector to emitter, and the voltage drop across RE. So we developed the KVL equation. Take equation number 1. Okay. But this IE almost equal to IC. So this can be written, okay, IC into RC plus VCE plus IC times RE, since IE almost equal to IC, which implies take IC as common, so RC plus RE plus VCE, this is my VCC. Take this is equation number 1 actually. Okay. So this is step 2 actually, right? Yeah, step 2. Step 1, to sketch the DC load line, sorry, DC equivalent circuit that already we have drawn. Now step 3. Yeah, step 3. What is the very first step? To find VCE. What do you want to do? You want to put IC equal to 0 and find VCE. Okay. Put IC equal to 0 in equation number 1. What you will get, if you will put IC equal to 0, you will end up with again same VC equal to VCC. Therefore, what is my reference point A? There is no change. VCC, 0. Then, to find IC, what is the procedure? VCE equal to 0 in equation number 1 and find IC. So this time if you will put a VCE equal to 0, then you will end up with IC equals, I equal to V by R. Here VCC divided by RC plus RE. Because output loop la RC, RE rendu per irukanga in series, so it will be added. So what is the reference point B? 0, VCC divided by RC plus RE. Kindly take this. So reference point A, VCC, 0, B. So there is no change in DC load line. So what we got for emitter bias, I hope so we have got the same reference point. Okay. So can you sketch it? Same story. This is my VCE in terms of volt, and this is my IC in terms of milliamps. Okay. And this is my DC load line. And take this point is A. You know the value VCC, 0. And take this point is B. This time this is 0, VCC divided by RC plus RE. So this is the way to sketch a DC load line for our universal hero, not Kamala Hasan. நமக்கு யூனிவர்சல் ஹீரோ சர்க்யூட்ல யாருன்னா வோல்டேஜ் டிவைடர் பயாசிங் தான். சரியா? What's the next step? Can you find Q point, right? So take it as an homework. நான் சொன்னேன்ல இதையும் யாரும் பண்ண மாட்டேன். But anyway, to find Q point. So Q point now you want to calculate VCQ, ICQ. Again same procedure. We know that IC equals beta times IB. So to find IB, if you will find IB, in order to find IB, you want to apply KVL at the input loop. This time, if in the loop you want to write IB. Is it possible by you people? Can you write IB by yourself this time without solving? When I get an if you will, this time VTH minus VBE divided by RTH plus 1 plus beta times RE, you will get IB. Then after that, you know how to calculate IC, which is equal to beta times IB, or IB equal to VTH minus VBE divided by RTH plus 1 plus beta times RE. Okay. Then to find VCEQ, apply KVL at output loop, and you will end up with VCC minus IC times RC plus RE. So this is my ICQ and this is my ECQ. So take it as a homework. Tomorrow I will start from here. Okay, how to find the Q point. So what is the change here? Here RB is replaced by, so that's a change. That's it. RB is replaced by this time RTH. So thank you. Thanks for your attention. Any doubt? Can I move to meet window?
Yes, sir.
Any doubt? Stalin இருக்கியா? Thank you. Thanks for your attention. For those who are having doubts, you can stay. And others, you can leave. Thank you, guys.